Hello, my name is John, and I am from 4th grade at Quail Valley Elementary School, and my project is titled The Big Bang. So, 13.8 billion years ago, the universe was a dot smaller than an atom. All of a sudden, the universe was free from its singularity. In seconds, the universe was changing. Astronomers are looking into the past to see the early universe and learn more about the Big Bang, due to they're not able to see directly the Big Bang due to radiation from it. You might be wondering, how do astronomers see into the past if they can't even time travel? Well, it's something to do with the speed of light, because even light has its limits of how fast it can go. And when then if you're farther than how fast the light can travel, you would seem that it's seeing at the exact same time as where it is, but really it's only a few minutes or maybe thousands of millions of years in the past. That's why when you look up into the night sky, you might see stars that are actually never been there, or at this time. Astronomers are looking into the deep field, which is what astronomers call far in space, using a telescope called the James Webb Space Telescope. Yet all of the pictures from James Webb all are red for things that produce light. The reason why is all of the deep field pictures are red because light of something called redshift. That's when light waves are stretched apart by the forces of speed and gravity. When that happens, the objects become redder and redder until they disappear into the infrared, which is why it's called infrared, because it's red. Same thing happens for when it's squished together, but usually you don't see that in space as well, because nothing's going to be pushed together unless something was coming at you. But this is not about blue shift. So, redshift is tricky to find stars because some of them aren't really stars at all. But we're able to find deep field objects because even though any deep field light images objects that produce light appear red. Cosmic expansion. The universe is always expanding due to the forces of the Big Bang. It's kind of like a balloon. If you put glitter in your balloon, and then all the glitters clump together until you blow it up. As you start to blow it up, if there's water in there, the glitter will be able to flow freely without smashing into each other or becoming a big clump. But eventually the balloon will pop, which shouldn't happen to the universe, hopefully, but that might happen. I doubt it, because it's not a balloon. Basically, as it expands, everything is being pushed apart, but instead of just being able to float freely, everything is being forced apart due to something called dark energy, which I'm not doing my project on because that's like a whole project, but formed from dark matter, which is basically nothing of nothing, something that contains nothing. We can't see it, we can't detect it with anything. Okay. So the conclusion of this project is that 13.8 billion years ago, the whole universe was a dot, and then it exploded. Within seconds, it was changing. 10 with the power of negative 32 milliseconds. Quarks started to form. Within 0.1 milliseconds, neutrons, protons, and electrons started to form. Within 1 second to 200 seconds, helium and hydrogen began to form. And then within 360 years, heavier elements such as iron, gold, platinum, uranium. Within billions of years, galaxies began to form, and eventually we have the present-day universe. Fun facts. The universe has no edge, side, middle, it's just a blob of something. A comic character from a comic I used to read said that he wanted to name the Big Bang horrendous space kablooey. And I think that's it. Yeah. Thank you for listening. Yeah, there's a lot of edit in that.